Hi students, as a part of corrosion, today I am going to explain the very important topic which is very important from the examination point of view as well as from the knowledge point of view. So that topic is theories of corrosion. So basically we have two theories of corrosion. The one is dry or chemical corrosion and the second one is wet or electrochemical corrosion. So before I explain the first theory, which is the dry or chemical corrosion, I would like to say that among the dry or chemical corrosion and wet or electrochemical corrosion, wet or electrochemical corrosion is the major destroyer of the metal because it is the one which mainly destruct or deteriorate the metal when compared to both. Now, let us discuss about the first theory of corrosion, which is dry or chemical corrosion. The name itself suggests what exactly is this particular corrosion. So there are two names associated with this particular corrosion. The first is, it is called as the dry corrosion. First of all, we have to discuss why it is called as a dry corrosion, because this particular corrosion occurs under dry conditions. So that is the reason it is called as the dry corrosion. And now let us see why it is called as chemical corrosion. This particular corrosion is called as chemical corrosion because this particular corrosion is due to the direct attack of chemicals such as atmospheric gases like oxygen, chlorine, hydrogen sulfide onto the surface of the metal. So that is the reason this particular corrosion is called as chemical corrosion. Now by combining both this, that is what is the dry corrosion, what is the chemical corrosion, which I have defined at the beginning, by combining both the definition, we can get the exact definition or precise definition of dry or chemical corrosion. So dry or chemical corrosion is the corrosion which involves the direct attack of the chemicals such as atmospheric gases like oxygen, chlorine, hydrogen sulfide, etc. onto the surface of the metal under dried conditions. So this is the precise definition of dry or chemical corrosion. Now this particular dry or chemical corrosion can be classified into three types. The first one is oxidation corrosion or corrosion by oxygen gas. Second one is corrosion by other gases. And third one is liquid metal corrosion. So first and foremost, we are going to discuss about the main corrosion of the dry or chemical corrosion, which is oxidation corrosion or corrosion by oxygen gas. Now the name itself suggests what exactly is the corrosion by the oxygen gas or oxidation corrosion. This type of corrosion involves the attack or the direct attack of the oxygen gas onto the metal surface under the dry conditions. And at both the temperatures, the metal is attacked by the atmospheric oxygen, or metals are attacked by the atmospheric gases. That is, at low temperatures, this oxidation corrosion or corrosion by oxygen is possible. At high temperature also, this oxidation corrosion or corrosion by oxygen gas is possible. Now let us see what are those metals which are attacked by the atmospheric oxygen and undergo the oxidation corrosion at low temperatures. At low temperatures, alkali and alkaline earth metals of the periodic table, that is first A and second group elements of the periodic table, are attacked by the oxygen gas at low temperature under dry condition and undergo the oxidation corrosion. Now let us see what are the metals which undergo the oxidation corrosion or attacked by the oxygen gas at high temperature. at high temperature except three metals of the periodic table, which are the noble metals such as silver, gold, and platinum. Except these three metals, all the other metals are attacked by the oxygen at high temperature and undergo the oxidation, corrosion under dry conditions. Now let us discuss the mechanism involved in this particular oxidation, corrosion, or corrosion by oxygen gas. And do remember that this particular oxidation, corrosion, or corrosion by oxygen gas is very, very important from the examination point of view. Now, let us say that this is one of the metal, and this is the surface of the metal. And this particular metal is in the environment where the oxygen concentration is more. Is in the environment where the oxygen concentration is more. This is the oxygen. Now, under the influence of the atmospheric oxygen, what happens initially is corrosion interface is created, or corrosion interfaces are generated. Interface in this perspective is, that is, the corrosion gates are opened. That is, the gates are opened for the corrosion. Once the gates are opened for the corrosion, then the metal undergo the oxidation corrosion. Now, as the metal is exposed directly to the oxygen, and here the concentration of the oxygen is high, right? Under this condition, already I've said that the corrosion interface is created or generated. This is how the corrosion interface is created or generated. Let us say that this is one interface, and this is the second interface. And what is the interface of corrosion, students? Interface of corrosion means the gates are opened for the corrosion to occur. Right. Now, when the gates are opened, what happens is, as this is the metal, let us say that it is a bivalent metal. Since it is a bivalent metal, it undergo oxidation. Oxidation is nothing but, already we know that loss of electrons. Let us say that it is the bivalent metal. Since it is the bivalent metal, definitely it produces M+2 ions and loses the 2 electrons. Right? Now, what is happening? When the corrosion interface is created, here we are discussing only about the two interfaces. It doesn't mean that only two corrosion interfaces are going to be created. Number of interfaces are created based upon the concentration of the oxygen. If the oxygen concentration is more, maximum number of corrosion interfaces are created. If the concentration of the oxygen is less, minimum number of corrosion interfaces are created. In order to exemplify, I have taken only two interfaces. So now what is happening? Under the influence of the atmospheric oxygen, the metal is undergoing oxidation and producing the 2 electrons. Now, whatever the 2 electrons which have been lost by the metal upon oxidation enters into the area where oxygen is present. Now, that particular oxygen gains the 2 electrons which have been entered into its vicinity and gets reduced to O minus 2. Gets reduced to O minus 2. Now, here what is happening, whenever the interface is created, the metal is undergoing oxidation and producing M+2 ions. And whenever these 2 electrons which have been lost by the metal upon oxidation are entering into the area where the oxygen is present, now that oxygen is gaining those 2 electrons and getting reduced to O minus 2. Now, M+2 which are formed here diffuses from their site O minus 2 which are formed here diffuses from their site. Now M plus 2 which have been diffused from its site reacts with O minus 2 which has been diffused from their site and converts to M2O2 which is nothing but MO. That is, metal oxide is going to be formed. Metal oxide is going to be formed. Now this metal oxide is going to be formed. Metal oxide is going to be formed. Now what is the metal oxide, students? The metal oxide here is the corrosive product. The corrosive product is the metal oxide. Now further corrosion depends upon the nature of the metal oxide which has been formed on the surface of the metal whenever the metal is exposed to the oxygen and undergoing the oxidation, corrosion or corrosion by the oxygen gas. Now whatever the metal oxide, before that another interface is there. The similar thing will happen here also. You will undergo oxidation and produces M plus 2 ions. Now whatever the M plus 2 ions and the 2 electrons have been lost in the similar fashion, same reaction. Now whatever the 2 electrons which have been released by the metal upon oxidation enters into the region where oxygen is present. Now the oxygen in the similar fashion undergo the reduction and produces O minus 2. Now M plus 2, O minus 2 combines together resulting in the formation of metal oxide. Now whatever the metal oxide which is formed here can be classified into 4 types. And this is the metal oxide which decides the further corrosion of the metal. So there are 4 types of metal oxides. That is, basically whenever the metal is undergoing the oxidation, corrosion or attacked by the oxygen gas under dry conditions, 4 types of metal oxides are going to be formed. The one is the stable metal oxide, the second one is unstable metal oxide, third one is volatile metal oxide, and fourth one is porous metal oxide. Now let us discuss one by one. First one is stable metal oxide. Stable means, already the name itself suggests that it is the stable one which is settling on the surface of the metal. Now let us see what are the examples of the metal on which this stable metal oxide is formed. The metal oxide which are formed on the surface of lead, aluminium, copper, chromium and wolfram. Whatever the metal oxides which are formed on the surface of lead, aluminium, copper, chromium and wolfram are of this particular type. Now second type of metal oxide which is going to be formed on the surface of the metal whenever the metal is attacked by the oxygen under dry conditions is unstable metal oxide. Unstable metal oxide. So unstable metal oxide means immediately after the formation of metal oxide, it dissociates into M plus 2 and O minus 2. It won't be on the surface of the metal. Now, whenever the metal oxide which has been formed is dissociating back to M plus 2 and O minus 2 ions, we can say that that particular metals on which the metal oxide, since it is dissociating into M plus 2 and O minus 2, we can say that those metals have not undergone the oxidation, corrosion. Those metals have not been attacked by the oxygen gas under dry conditions. And already I have discussed that there are 3 metals which do not undergo any sort of corrosion, which are silver, gold and platinum. Accordingly, we can say that the silver, gold and platinum do not undergo any sort of corrosion. Now, whatever the metal oxide which is going to be formed on the surface of the silver, gold, and the platinum is of this type. Now, coming to the third category of the metal oxide is volatile metal oxide. Volatile metal oxide. Volatile means evaporative metal oxide. Evaporative metal oxide. If it evaporates at once, if the metal oxide which has been formed on the surface of the metal is evaporating at once, then we can say that it is the unstable metal oxide. Since it is the unstable metal oxide, we can say that the metal has not undergone the corrosion at all. But it is volatile. It is volatile, and this volatile or evaporative metal oxide will not evaporate at once. It will evaporate in fractions. Some part of the, let us say that this is the metal. Let us say that this is the metal surface. Some part of the metal oxide is evaporated. Some part will be remain. Some part of the metal oxide is evaporated. Some part is remain. Some part is evaporated. Some part is remain. Now, when some part of the metal oxide is evaporated and some part is remained, what does it mean? It is creating the heterogeneity on the surface of the metal. It is creating the heterogeneity on the surface of the metal. Once the heterogeneity is created on the surface of the metal is more susceptible to undergo the wet or electrochemical corrosion, which is the major destroyer of the metal. Because for undergoing the wet or electrochemical corrosion, which is the major destroyer of the metal, definitely heterogeneity is needed. On the homogeneous surfaces, wet or electrochemical corrosion is not possible. But whenever it is volatile, what is happening, students? It is creating the heterogeneity. Once the heterogeneity is created, then it undergoes wet or electrochemical corrosion. Now, whatever the metal oxide which is going to be formed on the surface of molybdenum is of this type, MOO3, of this type. That this type means volatile metal oxide. So, molybdenum undergo vigorous corrosion. And the last type of metal oxide which is going to be formed on the surface of the metal whenever the metal is attacked by the oxygen under dry conditions and undergo the oxidation corrosion is porous metal oxide. So porous metal oxide means what, students? Porous means what? Whatever the metal oxide which is being formed, being formed contains or comprises the pores. Now by means of the pores, the oxygen entry is easy. Oxygen entry is easy. Oxygen entry is easy. Under the influence of which substance the metal is undergoing oxidation, students? The metal is undergoing oxidation in the presence of oxygen. Now, whatever the metal oxide, if it is porous in nature, what will happen by means of those pores? The oxygen will penetrate inside the metal, thereby resulting in the formation of the heterogeneity. Once the heterogeneity is created, the metal cannot be stopped from the wet or electrochemical corrosion. So it is very dangerous metal oxide which is going to be formed on the surface of alkali and alkaline earth metals. Alkali and alkaline earth metals. So, dear students, remember that among the oxidation and reduction, corrosion is oxidation. Corrosion is oxidation, and for undergoing the dry or chemical corrosion, homogeneity is sufficient, but for undergoing the wet or electrochemical corrosion, definitely heterogeneity is created. And when the metal oxide which is going to be formed on the surface of the metal, whenever the metal is directly attacked by the oxygen gas under dry conditions are undergoing the oxidation corrosion, then heterogeneity is created. Once the heterogeneity is created, definitely it undergo the wet or electrochemical corrosion. And already I've said that the wet or electrochemical corrosion is the major destroyer of the metal. It is the one which mainly distracts or deteriorates the metal. So in this particular video, I've explained only about the oxidation corrosion or corrosion by the oxygen gas, which is one subtopic of dry or chemical corrosion. In the next video, I will discuss about the two other types of corrosions which are a part of the dry or chemical corrosion. The first one is second with respect to this first is oxidation corrosion is corrosion by other gases. Next one is liquid metal corrosion. I hope you understood this concept. This concept is very, very important from the examination point of view as well as from the knowledge point of view, students. So thanks for watching. If you really like the video, please do comment on the video and subscribe.